Hello learners, I am Dr. Nidhi Singh, Assistant Professor Geography. Today we are going to learn about evolution of landforms due to internal forces. Now we see lots of variety of landforms on the earth's surface, plains, plateaus, hills, trenches, etc. So there is a relationship between the rock types and the shape of landforms. The kind of rocks that are present on the earth's surface determine the kind of landforms that are generated out of it. And there is deformation of on the earth's surface due to continuous influence of internal as well as external forces. In the earlier sessions we have we learnt about internal as well as external forces acting upon the earth's surface. So today again we will be dealing with it in detail. So today we are going to learn about the endogenetic forces, different types of forces and how they affect the landforms. Now in precisely today we will be learning about endogenetic forces that transform landforms, then types of endogenetic forces, folds, faults, volcano, earthquake, etc. So first of all, what are endogenetic forces? These forces generate, as we all know, from internal of the earth's surface. The two forces acting on the earth's surface, that is endogenetic as well as exogenetic, they work simultaneously and continuously. So as soon as some force starts, it's not necessary that once it will stop and then again then the second one will start, but they work simultaneously many a times. So forces working inside the earth are known as earth movements, and they are also known as tectonic movements because they generate because of movement of the earth surface, I mean the plates. So the tectonic movement results in the movement of earth surface, and these are the internal forces that we know. We have learned in detail about tectonic movements in the earlier sessions. Now tectonic, as we know, is derived from the Greek word tecton, which means builders. Earth movements are constructional in nature and they are responsible for building different types of landforms. Some of the examples of endogenetic forces and the resultant landforms are submergence of forest in Bombay harbour. Second is Mahabalipuram temple which is now standing on the sea. Then changes in ground level in run of Kutch of Gujarat. So these are some of the examples of forces that generate, I mean, different landforms, that are examples of endogenetic forces. Now what are the types of endogenetic forces? There are two main types of endogenetic forces. One is slow movement and another is sudden movement. So as the name suggests, slow movement act very slowly and sudden movements act very fast. Suddenly they act. So first of all, slow movement, it brings changes on Earth's crust very slowly. It takes hundreds of thousands of years to act, and it covers a period of much longer time span than a human lifespan. So it acts on Earth's surface either vertically or horizontally. The second type of forces are sudden movements. So these bring abrupt changes, sudden changes on the Earth's crust. And the examples of such movements are volcanic eruptions and earthquakes. Lava flow, landslides, all these are sudden movements that take place on the Earth's surface. Now slow movements are again of two types, vertical movements and horizontal movement. Vertical movement is again of two types, upliftment and subsidence. So now we will be dealing with vertical movement, that is a type of slow movement. It originates from Earth's center. There is large scale upliftment or subsidence. Upliftment, the Earth's surface rises, or subsidence means it subsides down, it goes down. So it is large scale upliftment or subsidence of part of Earth's surface. It is slow and widespread and there is no change in horizontal rock strata. Now vertical movements are associated with formation of continents and plateaus. So they are also known as continent building or plateau building movements. These are also known as epirogenetic movements. Epiros in Greek means continent. And there are two types of vertical movements, one is upliftment and subsidence. Evidence of upliftment are sedimentary rocks deposited and formed in oceans and seas. Then presence of these rocks is widespread in continents. Evidences of submergence is submerged buildings, rivers, valleys, and cities, etc. Submerged ancient buildings in Mediterranean in Crete Island and ancient city of Dwarka or Saurashtra in India. These are some of the examples of submergence. Now second is horizontal movement. It causes lots of disruption in horizontal strata. It involves lots of compression and tension of pre-existing rocks. It acts horizontally or tangentially to Earth's spherical surface. There are two types of horizontal movement. One is forces of compression and another is forces of tension. Now, forces of compression. What are forces of compression? It is pushing of rock strata against a hard plane. So, the rock strata is compressed. It comes together and it gets compressed, crumpled. This happens from one side or from both the sides. It results in bending of rock layers. Formation of fold mountains are the example of forces of compression, resultant of forces of compression. So, for example, if you see this piece of cloth, when force is applied from both the sides towards each other, this is known as forces of compression. And what happens? Fold has taken place. So, in this manner, suppose this is a rock strata. Suppose this piece of cloth is a rock strata and forces of compression is acting on it. So, what happens? It is compressed and the rock strata is getting folded. So, in this manner, when the large, very huge area, very large, vast area is compressed in this manner, so folded mountains are formed. Himalayan is an example of such fold mountain. What is exactly folding? The process of bending, warping and twisting of rock strata is known as folding. I will repeat it for your ease. Process of bending, warping and twisting of rock strata is known as folding. The resultant landform out of it is fold. It is a wave-like structure with upfolds and downfolds. The upfold, suppose this is the fold. So, this is the upfold and this is the downfold. So, this is known as anticline and this is known as syncline, the downward portion. Himalayas, Rockies, Andes, Alps and all etc. are some of the examples of mountains formed out of this process. It helps in mountain building process and therefore it is also known as orogenetic movement. This is the example of fold as you can see in the picture. These are anticlines and synclines. This is the fold, a wave-like structure. Now, forces of tension. We have now earlier we learnt about forces of compression. This is forces of tension. When these forces work horizontally in opposite direction. So, when the force acts horizontally in opposite direction, I mean pulls. So, that is known as tension. Like a rubber band, when we stretch a rubber band, what happens? Apart from each other, I mean in different direction, the tension is created. So, on the earth's surface also, when forces are acting opposite to each other, then force of tension is created. Intense tensional force result in breaking of rock strata or which results in fracturing, and so the cracks and fractures develop. There is displacement of rock upward or downward from original position also, and along this fracture, and this is known as faulting. So, the fault is a line along which displacement of fractured rock strata takes place. This is known as fault line, and the plane along which displacement of rock strata takes place is called fault plane. The line along which displacement takes place is known as fault line, and the plane along which the displacement takes place is known as fault plane. As you can see in the diagram, the red line which is marked is the fault line along which displacement occurs. So, the upper portion is the upthrown side which is thrown upwards, and the second one is the downthrown side which goes down, and there is a fault line, fault plane is there, and this is the example of a fault and different related features of fault. Now, another thing that happens is volcano. Different types of landforms, different type of processes that occur due to this folding, faulting and fracturing is volcano. Volcano is a vent or an opening in Earth's surface through which molten rock material, rock fragments, ash, steam, gases and other hot gas etc. come out. These can be slowly or forcefully or violently. This is an example of volcano. We must have seen, you must have seen it in the pictures or movies or somewhere else in photographs etc. So when magma, we have discussed earlier also that when magma comes out, it is known as lava. So when it's inside the earth surface, it's the molten material. When it's inside the earth surface, it's called magma. When it comes out of the earth surface, it's called lava. So magma is coming out and in the form of lava, and there is a crater, a funnel shaped feature is created, and that is known as crater, and when it's get deposited outside, it forms a cone. So this is an example of simple volcano, commonly found volcano. Now from where does this molten material comes out? It comes out from hot interior of the earth. Vent occurs in earth's crust and rocks wherever rock strata is weaker. A vent means opening. So wherever there is a weakness or weak rock strata, an opening or vent is created, and from there the molten material comes out. You must be thinking why such eruption takes place. What happens that extreme heat and pressure is created inside the earth's surface. So what happens because of that? The molten material or the magma gets pushed, it tries to come out because of the intense heat and pressure. So what happens, wherever there is a line of weakness, the molten material escapes from the earth's surface through that line of weakness. Now tremendous force of magma or gases is there, which comes out from the hole in the earth's crust, and magma comes out. So the process by which solid, liquid and gaseous materials escape from the earth's interior is known as volcanism. So the process of eruption of volcano is known as volcanism. In simple language, the process by which volcanoes takes place is known as volcanism. What are the different features a volcano has? There is a pipe through which the magma comes out. Then there is a cone that is formed when the magma, hot gases, ash etc. come out. A cone is formed, and then crater, that is a funnel shaped depression at the top of the cone. So at the top of the cone there is a funnel shaped depression, and this is known as crater. So there is a pipe, there is a crater and there is a cone that is formed. This is a basic feature of a volcano. There are different types of volcanoes. So on the basis of frequency of eruption, how often a volcano erupts, it's of three types. One is active volcano, second is dormant volcano, and then third is extinct volcano. Active volcano is the one which erupts frequently or has erupted recently or are in action currently. Example of these volcanoes are Stromboli, Krakatoa, Mayon, Mauna Loa and Barren Island. Barren Island is located in India, that is in Andaman Nicobar Islands. So these are the examples of active volcano that have been erupting frequently or has erupted recently or still in action. Its eruption is taking place right now. The second type of volcano is dormant volcano, which have not erupted in recent times. It is also known as sleeping volcanoes. An example is Vesuvius and Cotopaxi. The third type of volcano is extinct volcano, which have not been erupted in historical times, and the example is Mount Popa and Mount Kilimanjaro. Now this was on the basis of frequency of occurrence. Now the second type is on the basis of mode of occurrence. So according to this mode of occurrence, there is central type and the second is fissure type. Now central type of volcano, eruption takes place from a vent or a hole. Different types of domes, conical hills etc. are formed depending on nature of erupted material. The majority of volcanic eruptions in the world is of this type, that is central type, and violent explosions also take place when there is sudden escape of gases and molten rocks through this hole. Example of such type of eruption is Vesuvius and Fujiyama. You can see the example in the picture, you can see the central type, it's violently erupting. Now the second is fissure type. Here if there is a crack or a elongated deep crack, so what happens, magma comes out slowly, not violently, it flows out of these fissures or cracks. So it gets developed due to earthquakes or faulting also. Formation of thick horizontal sheets of lava or low dome shaped volcano is landform, such type of landform takes place. That means a sheet of lava flow, a sheet is created horizontally, or a low dome shaped volcano can be seen, I mean landform can be seen. It also forms lava plateaus and lava shields. Example is Deccan Trap of India. Now this is an example of fissure eruption. You can see long elongated cracks and lava is coming, hot gases is coming out of it. It's not violently coming out. Now another type of classification is on the basis of fluidity of lava, how fluid the lava is. Depending upon this, one is volcanoes of basic type and second is volcanoes of acidic type. Basic lava volcano are formed of basic lava and it is rich in metallic minerals, it has low melting point, it has greater fluidity, that means it flows very fast. So lava flows far and wide, quietly with greater speed, then it spreads out in thin sheets over a large area. There is a formation of shield and lava domes. Examples are shield volcano of Hawaiian island in the Pacific Ocean. Now in the picture you can see the fissure eruption of and formation of shield. It's flowing, the lava is flowing and it's getting solidified. So shield or sheet is formed. Now the second type is acidic lava volcano, which is formed of acidic lava. Acidic lava is rich in silica, it has higher melting point, it's highly viscous and solidifies quickly. So higher land features with steeper slopes is formed. The difference between acidic and basic lava volcano cones can be seen in the diagram. First one is lower height of landforms and second is higher. Now distribution of volcanoes. How, in what manner and where the volcanoes are distributed on the earth's surface. In the earlier sessions also we discussed about it in a brief, like ring of fire and all those things. So we will be dealing with it again in this session again. So there are almost 500 volcanoes in the world and they are mostly found in three important belts. One is the Circum-Pacific Belt, that is also known as Ring of Fire, which is located around the Pacific Ocean, and the second is the Mid-World Mountain Belt, and the third is African Rift Valley Belt. So these three are the main important zones where volcanoes occur on the earth's surface. Volcanoes are closely related to regions of intense folding and faulting. Now in the picture you can see the distribution of volcano. So around the Pacific Ocean there is a ring of fire that is shown. The whole series, I mean in a ring circular form, there is occurrence of volcano. So these red dots you can see is a volcanic places from where volcanoes happen or volcanoes erupt, and it forms a ring kind of thing. So this is that, and then another is the mid-world mountain range, which is found around the mountain ranges of the continents, internal side of the continents, and then there is African Rift Valley belt that is found in African Rift Valley area. Again we will be discussing about the distribution of volcanoes in detail. So it occurs along coastal mountain ranges within the larger area. It occurs along coastal mountain ranges on the islands and in mid oceans. So these are the further categorization of the location of volcanoes where they are formed. So they are found along coastal mountain ranges, on islands and in mid oceans. Interior part of continents are generally free of volcanoes. Most active volcanoes are found in the Pacific region because the ring of fire is also located there. 83 active volcanoes are found in Mediterranean region. Now another process or another thing that happens on the earth's surface apart from volcanic eruption is earthquake. What is earthquake? We all must have felt some or the other time, we must have felt a vibration in the earth's surface on the ground. So that is known as earthquake. Earthquake is a motion of ground surface. It ranges from faint tremors, very light tremors, very light shaking of ground, to wild motions, very strong shaking on the ground. The form of energy of wave motion is transmitted through surface of the earth. Earthquakes vary in intensity, that means they can be very mild or they can be very strong. Dozens of earthquakes occur every day on the earth's surface. Very mild, we might not feel it many a times. So dozens of them occur every day. But severe earthquakes happens or takes place in few regions. Instrument used for recording earthquakes are known as seismograph. In the picture, you can see a seismograph and how the recording is being done. The needle, the needle writes, ink is there and it forms a wave kind of pattern, and this is the measurement of earthquake. So, how intense the earthquake is taking place. So, the variation is accordingly. So, it is a seismograph and how the with seismograph earthquake gets recorded. Now, the point within inside the earth's surface from where earthquake originates, it is called focus. So, the focus is the point from where earthquake originates, and this is located inside the earth's surface. It is also called seismic focus. So, seismic means related to earthquake. It is also known as seismic focus. The seismic focus or the focus lies almost 60 kilometers beneath the earth's crust. The point vertically above the focus is known as epicenter, and this is located on the earth's surface. Focus is located inside the earth's surface and the point vertically above the focus but located on the earth's surface is called epicenter. You can see in the picture focus, which is located inside the surface, and the vertical point vertically above the focus on the earth's surface is epicenter. Earthquake waves originate from focus. They travel in all directions. The intensity is highest at the epicenter, that is on the earth's surface vertically above the focus. So, maximum destruction also takes place at and around the epicenter. What are the causes of earthquake? The most important cause of earthquake is folding, faulting and displacement of rock strata. Examples: San Francisco earthquake that was caused in California, Assam earthquake that was caused in India, and Bihar earthquake that took place in India in 1935. Now, another cause of earthquake is volcanic eruption. Violent volcanic eruptions result in vibrations but are limited to areas of volcanic activity only. Example is earthquake continued for 6 days post eruption of Mauna Loa volcano in Hawaii Island in 1868. Now, another cause of earthquake is landslide, collapse of cavern or cave, or underground mines and tunnel. So, these are the factors that cause minor earthquakes. Now, effects of earthquakes are: violent earthquakes can be very disastrous, and they cause landslide, damming of river course, floods, depression leading to formation of lakes, cracks and fissures in earth's crust, changes in the direct drainage system. Other effects are displacement of rock strata vertically and horizontally along fault line. Fire also takes place at times. Seismic sea waves take place, or seismic sea waves originate, and they are known as tsunamis. They originate in sea, and we have heard about and we saw seismic activities in sea and tsunamis in India also. So, distribution of earthquake, phenomena of almost every part of the world. So, it takes place in different parts of the world, and two important belts that are that can be identified where it is most frequent. It is circum-Pacific belt and the mid-world mountain range, similar to that of occurrence of volcanoes. So this is the picture where you can see map. Again, it coincides with the place where volcanic eruptions takes place. So in this session, learners, we learnt about evolution of landforms with the help of endogenetic forces, then types of such forces, endogenetic forces, slow, sudden, vertical, horizontal, etc., and then fold, fault, volcanoes, earthquakes, etc. I hope you must have understood it, and will be dealing with some other topic in the next session. Thank you.